All right, so our targets for today, we're going to talk about sine, cosine, and tangent using the unit circle. And you're thinking, well, Ms. Moore, we already did that. You're right, we did. But we're going to look at it in a little different context, okay, in terms of how they're going to assess you on the exam. And then we're going to determine coordinates of points on a circle that's centered at the origin. Notice it doesn't say unit circle, it says a circle. And so we're going to talk about how what we know about the unit circle extends to all circles, all right, which is nice. So is this crooked? Okay, it's freaking me out. Oh, there it is. I was like, this thing is crooked. Okay, that's probably still crooked. That's a little better. Okay, so let's start with, shower of sadness. Okay, so let's start with what we call the periodic definition of angles in a circle, okay? We talk about something called standard position. So these are just terms you're going to see within some of the question stems, and I don't want it to freak you out, okay? So standard position just means that for our angle inside of our circle, the vertex is at the origin, and one of the rays, okay, is on the positive x-axis. Okay, so if they ever say this is an angle in standard position, it's centered at the origin, okay, and one of the rays is on that positive x-axis and we're opening up, okay? So that's all that means. It's just a definition, right? The second terminology or term that you'll see them use is called the terminal ray. It's the other one, okay? I mean, it's the second ray or your ending ray of your angle in standard position. Right. Just a little bit of new vocabulary right there. Now, one of the things we're going to do today is we're going to marry right triangle trig with your unit circle trig, all right? Because they do play together, and they help us to evaluate angles and coordinates for things that are any circle and not just a unit circle, okay? So we have to kind of make them play nicely together. So I just want to go back and review that from geometry, okay? So your right triangle definitions for your trig functions. We're going to start with just sine, cosine, and tangent. So here we have a right triangle, all right? And let's label our right triangle. Let's say, what do we always call the long side? That's our hypotenuse, okay? Right? But if I put an angle in there, theta, right? We refer to the legs of the triangle as opposite and adjacent. Okay, opposite meaning it doesn't touch the angle, adjacent meaning it does. Okay, so there's my hypotenuse. The one touching the angle would be my adjacent side, and the one not touching my angle would be my opposite. Okay, and by angle, I'm referring to theta. All right, not the right angle or the other angle. So, how many of you remember that little phrase we use for right triangle definitions of trig functions? SOHCAHTOA, right? It's important you know how to spell it. Okay, so I had some students very early in my career come up with this statement, and I'm just going to share it with you, okay, because they couldn't remember how to spell SOHCAHTOA, okay? Some old hippie caught another hippie tripping on acid, okay? And I've used it ever since because I never forgot it from that moment, okay? So, SOHCAHTOA, some old hippie caught another hippie tripping on acid. So, if we list our definitions, sine of theta is opposite over hypotenuse. Cosine, helps if you put the C there, of theta is adjacent over hypotenuse. And tangent is opposite over adjacent, right? Now, that's all you learned in geometry, right? But in trig, we found out there are three more functions. Okay? There are three more functions. And so we get those from reciprocals. So cosecant is 1 over sine. So we take opposite over hypotenuse and we flip it. Okay? Secant then would be 1 over cosine. And cotangent would be 1 over tangent. We're just going to flip them. They are reciprocals. All right? Now, another piece of information that's going to be really useful for me when I'm working with these problems is something that helps me get the sides of my triangle. There's this magical formula that we've done since middle school that we use to get sides of a triangle. What is it? The Pythagorean theorem. Okay, a squared plus b squared equals c squared. So we get that, okay? All right. So what I want to do in the next slide is show you how we combine these two things. How do we combine SOHCAHTOA type relationships with what we know about moving around the unit circle? Right? So let's get those written down. And that's what we're going to do. So we're going to focus primarily on that today. All right? Marrying these things together. Key lime cotton candy. It's pretty good, little tart, little sweet. Yeah, so I got totally judged in first block today because we did a lesson. We're down to, tomorrow's our last new lesson in calculus. It's a big day. But our last 3 lessons are about, we use food to help illustrate and get through what we're doing. So we had pears today that we were slicing up, and they were like appalled that I had never eaten a pear, ever.
Really?
Yeah, never. Yes. No, because we were touching it and stuff, so I didn't eat it, no. Tomorrow we have bagels, so they can eat those, but yeah. But little ones, they're little ones. And I brought cream cheese. I have savory and sweet, so they can choose.
Eat a pear, you need to cut it up in slices.
Okay.
Just eat it.
Don't eat it like with the skin and stuff, like an apple?
No, I mean, you can eat the skin, but I suggest cutting it.
Okay. I'm going to try one. They kept telling me that it's mushier than an apple, but it's sweet like an apple. Okay. All right. Something to do. It's just a piece of fruit I've never eaten. So, anyway. Okay. Am I alone in that? Anybody here never eaten a pear? Okay. Yay, I'm not alone. Okay. All right. Apparently, I was alone in first block. All right. They were like, your parents don't love you. No, I'm just kidding. All right. So, let's talk about how all of this comes together. Okay? How does everything that we know about the right triangle and everything that we know about the unit circle come together? All right? So one of the things I want you to notice, they drew this circle here for me, thank goodness, because it's much better than what I could draw. Okay? So on our circle, there's our point 1. Every point has a coordinate, an X and a Y. Okay? An X and a Y. And so to get to that point, I graphed over X and then up Y. Okay, so that's how I got there. When I do that, it creates what kind of triangle? A right triangle, all right? And so what now does our hypotenuse represent in terms of my circle? Distance from the origin to the circle, which is also known as the radius, okay? So x squared plus y squared equals my radius squared. Okay, so that's what it is. Now, let's talk about how we would get my cosine. Okay, how would I get cosine of theta if we're thinking right triangle trig? There's a right triangle there. Okay, so cosine is going to be what? Adjacent. So which side is adjacent to theta? X. And my hypotenuse is r. Okay? In the unit circle, cosine was equal to x. Why? What was r in the unit circle? 1. So what's x over 1? just x, okay? So that's why in the unit circle, cosine is just x, because the radius is 1, all right? So then what would sine be of any circle? Y over my radius, okay? Opposite over hypotenuse. So, okay, cut, and then so, and then let's do TOA. Okay, tangent is going to be what in terms of the right triangle? Opposite over adjacent, y over x. As we said in the unit circle, sine over cosine. Okay, so it's all the same stuff. All right, we've just labeled it differently. Now, I want you to look, if I think about the radius as a line, okay, as a line, what's tangent the same thing as? It's slope, right? It's rise, y, over run. So this tangent is the same thing as the slope, all right, of that line going through that ordered pair, okay? So it's just some really neat connections, how all of that is the same stuff, okay? Things that you've worked with for forever, okay? They're all the same right there. All right, so let's do a couple of a multiple choice example and then one that's not, okay? So it says, the figure shows a circle centered at the origin with an angle measure of theta in standard position. So there's that terminology, okay? So we've got one of the rays is on the x-axis and then the other one that goes to a point, all right? The terminal ray of the angle intersects the circle at point P. So it's just telling me, hey, you got an angle in here, all right? And this gives me theta, all right? So here's point P. Okay. Then it says the coordinates of P are x comma y. Which of the following is true about the cosine? So I go over x and up y. So x comma y. All right. What did it tell me the radius of my circle was if I look really close in there? It's 3. So that means my hypotenuse is 3. Okay. So they told me the radius was 3 if I look in the circle. And it's asking me about the cosine, okay? It's asking me about the cosine. And so if I'm thinking my right triangle, all right, so the cosine of theta would equal, so cut adjacent over hypotenuse would be x over my radius, which was 3, okay? So what's my correct answer? It's A, okay? And look at the reasoning. I think this is interesting. It says because it's the ratio of the horizontal displacement of the point from the y-axis, all right, to the distance between the origin and P. So it's just speaking about all of those things. The horizontal displacement, how far did I go left and right? Over my length of my radius, okay? It's what it's saying. So it's using big math words to say adjacent over hypotenuse, all right? So it's just using big words. Question about that one, all right? They're going to give you some of those kinds of questions, which are nice, all right? But you got to think through the words, okay? All right, let's look at the next one, and I really like this one too, okay? All right, it says the figure shows a circle with a radius of 5 centered at the origin with an angle of measure theta in standard position. The terminal ray of the angle intersects the circle at point P, and we want to find some values. Now, I want to show you something. They have moved my triangle, all right? Which quadrant did they move it to? The 4th quadrant, all right? So when they move it to the 4th quadrant, we're going to use what's known as a reference angle, all right? We're going to move our theta inside that right triangle, all right? We're going to move our theta inside that right triangle. This is point P, all right? Now, look what they happen to give me. They gave me point 1. We're looking at point 4 down here. What are the coordinates of that point in that 4th quadrant going to be? 3, negative 4. Okay, 3, negative 4. It's just in a different quadrant. It's the same point in a different quadrant. Okay, so that means I went right 3 and I went down 4. And then what did they tell me my radius was? 5. Okay, so that's my hypotenuse. All right. So again, marrying all of that different kinds of trig together, we had a right triangle. Okay, so using that triangle, there's my theta. I want to find sine, okay? Sine, opposite over hypotenuse. What would be opposite to this theta? -4 over 5. Does it make sense that that y coordinate's negative? It's in the fourth quadrant, okay? What would cosine of theta be? 3 over 5, okay? And what would tangent of theta be? -4 over 3, opposite over adjacent, okay? So I'm using right triangles. Now, if they had not given me the radius, could I have found it? Sure, could do Pythagorean theorem and get the radius that I'm missing. All right, questions on those two? Okay, much better than those graphs. Yes, confirm. I confirm. All right. Okay, so let's look at these next couple. All right. So this time, we just want to take it real general. All right, and we pretty much hate that, okay? But that's what we're going to do. So they give me point 1, all right, which is point P. Then they ask me about the coordinates of Q, R, and S. Okay. Can we do that using what we know about a unit circle? Yes, do that for me. Okay, go ahead and give me the coordinates for Q, R, and S. All right, they tell me P is X, Y, so let's get the rest. Okay, so point Q is in the second quadrant, so it would be what coordinates? -x, +y. Point R is in the third quadrant, -x, -y. And then point S is in the fourth quadrant, so x, -y. Okay, so we all good with those points, all right, where they came from. So now it's going to ask me to do some things. It says to find the sine of the angle whose terminal ray intersects the circle at point S, okay? So we're thinking about point S, right? So I'm thinking about that right triangle at point S, okay? So to get that triangle, I went right X and I went down Y. And then what's the hypotenuse always going to be? The radius, okay? So if I want sine of that angle, so sine at theta, all right, is going to equal opposite. So here's my theta inside my triangle. Opposite over hypotenuse, or -y over r. Okay? Your theta that you're going to look at always touches the x-axis in that quadrant, okay, for your right triangle. See if you can do 5 and 6. Okay. So let's look at these. This time I want cosine at point Q. So let's do point Q. There's my right triangle. All right, which means theta's in there in the middle. That means I went a negative x and a positive y, and r is still r. Okay, so if I want cosine of theta, so using that green triangle, cosine adjacent over hypotenuse, which side is adjacent to theta? Negative x, and my hypotenuse is always r. Okay. All right, and then last one, we're talking about point R. I'm going to do it in red. Okay, so my theta is there at the origin. Okay, so this time I go a negative x and a negative y, and r is still r. So tangent at theta, okay, opposite over adjacent, so negative y over negative x. What could I do with those negatives? Cancel them out, I get y over x. All right, what do we think about that? Okay, well, let's just ramp it up a smidge. Okay, not a lot, just a little. Okay, yes, ma'am.
How do you know which triangle to use?
Okay, it depends on the point. All right, so if I'm using point R, to get to point R, I'd go left and down, so a negative x and a negative y. Okay, that's all I always think about. Which quadrant am I in? I'd go left and down.
So you always start with X?
Yes. Okay, just like graphing a point. Yes, ma'am. All right, look at this one. So this time we've got this whole circle, but they tell me that their terminal ray coincides with the line y equals negative 3x in quadrant 2. Okay, so I'm going to sketch me a circle. And then I'm going to sketch the line y equals negative 3x, all right? Because that's going to be important, right? Negative 3x. So negative 3x, I'd have 0, and then I have a slope of negative 3. So down 3 over 1, and then up 3 back 1, all right? Okay. All right, that's going to be important to us in just a second. It says it's going to, where it crosses, the terminal ray is in quadrant 2. So it means it ends in quadrant 2. The point that I'm interested in is in quadrant 2. All right, everybody good with that? Okay. How would I graph to get to quadrant 2? Which way would I go first? Left and then up, okay? And I do that just to get my triangle, okay? I go left and then I go up, all right? I know theta is this angle, okay, at the origin, all right, that I'm going to use as my reference, okay? Now, what makes this one tricky is that they gave me a line, okay? But that line's important because if I look at that equation, y equals negative 3x, we said earlier that any line, any radius is also, or tangent is also what? It's the slope, all right? Tangent is the slope, okay? So the slope of that line is my y over x, okay? So let's look. The slope is negative 3, all right? So negative 3 equals y over x. Lo and behold, if I had gotten negative 3 by itself, that's what it would have been, okay, in that equation above it. So I know that tangent of theta equals y over x, all right, because it's my slope. Right. All right, so my tangent is just negative 3, right? Now, here's the fun part, okay? Let's think right triangle, all right? Negative 3 over 1. If I was graphing, okay, x is 1, but does x have to be the positive or the negative value right here? The negative in that quadrant. and then the y would be positive. Does that ratio still give me -3 for y over x? Yeah. Could I find the radius? Yep. I could get r squared by taking -1 squared plus 3 squared. So r squared would equal 10. And so what would my radius equal? Square root of 10. Okay? It's good. You don't have to simplify that radical. Okay? It's all right. It happens all the time. I mean, I got sprayed with water that I could have totally controlled today. So it's all good. No harm, no foul. All right. So now that we have our triangle, we have our values that we need. Okay. So we had to use a little trig to know that tangent was my slope. Okay. Or you could have just solved for y over x. That's tangent. All right. To get -3, we put it in the circle in the right place. All right. So y had to be positive because I'm in the second quadrant. X had to be negative. Now let's do the other things. All right. Sine at theta. All right. Sine at theta. Sine is opposite over hypotenuse. 3 over the square root of 10. Okay. I'm not going to make you rationalize this. Okay. For right now. All right. But if you did, you'd multiply by square root of 10 over square root of 10. So you'd have 3 square root of 10 over 10. Okay. But I'll keep 3 over square root of 10. All right. Cosine. All right, adjacent over hypotenuse. Be careful with your signs, S-I-G-N. So I'd have a -1 over the square root of 10. And tangent we already knew was -3. Okay. So question about using the circle and the right triangles within it. Okay, you kind of have to marry it all together. All right, to know which quadrant we're in terms of the point. What does that mean in terms of my x's and my y's and my triangle, my lengths, and my radius, my radii. Okay. I need to double check something. Hang on. Okay, all right, I thought so. All right, you know how you sometimes you second guess yourself? That's my life right now. All right, so again, let's talk unit circle. How do I do a positive arc length? Which way do we go? We go counterclockwise. That's going to be important to us here in just a second. And what do I do for a negative arc length? We go clockwise. Okay, so again, none of that changes, even if I have a different radius in my circle. All right, the next thing they're going to ask me to do is to actually measure some angles. Okay, and what we're going to do is we're going to think unit circle for this. Okay, and by that it means we're going to ignore the radius. All right, it's not going to be important to us. All right, and we're going to answer every question by thinking or looking about what part of 2 pi am I looking at. All right, and we'll do that based on how much of the circle that they give me. All right, what part of 2 pi am I considering? All right, I'm not going to look at the whole circle. Why would we say 2 pi? Yeah, it's my circumference. It's my total distance around. So we're going to think about a portion of that circumference. All right, so let's look at this one. It says to consider the angle theta created by the quarter circle of a radius 4 above. So here is the portion of the circle I'm talking about, okay? All right, it's a quarter circle. How much is that? It's 1/4 of the total, which is 2 pi. What would that simplify to? Pi over 2. And that's your answer. Right? That's all we're doing is considering a portion of the unit circle. Okay. All right. Let's look at all the ways that they could ask me questions. All right. Find the measure of the angle formed by a third of a circle with a radius 3 centered at the origin, this is important, in the clockwise direction. All right, what does that mean is going to be true about my angle? It's going to be negative. Okay, so that's why we have to think about direction. All right, I want how much of a circle? A third of it. All right, but we know it's going to be negative because I'm going in the clockwise direction. All right, and then I just simplify that multiplication, negative 2 pi over 3. These are probably some of the easiest ones we do. Right? See if you can do those underneath it. You do not have to sketch a picture. All right, so let's take a look at these. I want 1/6 of a circle. All right, so 1/6 of 2 pi. Okay, if I'm going counterclockwise, will it be positive or negative? Positive. And so 2 pi over 6 would reduce to pi over 3. Okay. All right, the next one. Theta equals 2 full revolutions. All right, so 2 times 2 pi, all right, because I want to go full revolution. In the clockwise direction, positive or negative? Negative. So I'd have negative 4 pi. Okay, so I didn't want a fraction this time. I wanted 2 full revolutions. The next one, 3/4 of a circle in the counterclockwise direction, positive or negative? Positive. That gives me 6 pi over 4 or 3 pi over 2. All right. 7/8 of a circle in the counterclockwise direction, positive or negative? Positive. 14 pi over 8 would be 7 pi over 4. Question on those. So just thinking about a portion of that full revolution, which is 2 pi. Okay? When? Okay, we got those. We're going to rock through those. Those will be the give me problems on the exam. Okay? Let's look at this next one. Right? Again, it's just going to use a lot of words to do something relatively simple. Okay? So it says point R is the result after point P is reflected over the y-axis. Okay. If I reflect P over the y-axis, which quadrant is my point going to land in? 2. All right? So that's the first thing we had to figure out. If I land in the second quadrant, what's my ordered pair going to be? Negative, positive. Okay? And then this is where I can go back. So it says, that's alpha, by the way. Be the angle in standard position whose terminal ray intersects the circle at the point R. All right. So basically, here's my right triangle, and they're calling that angle alpha. It looks like a fish. Okay. Now, the good news for me is that they have already given me the ordered pair. Okay. They have given me the ordered pair. And so I can do sine, cosine, and tangent like I'm used to doing it from the unit circle. Right? Even though they didn't tell me this was a unit circle, we can approach it the same way. I don't have to go through the right triangle, all right, and get crazy hypotenusae and all that kind of stuff, right? So what would the sine at alpha be? Which coordinate? The y coordinate. So it would be square root of 3 over 2, all right? What would cosine at alpha be? It'd be our x-coordinate, which is 1/2. And then tangent of alpha would be y over x, or square root of 3 over 2 divided by 1/2. Square root of 3 over 2 times 2 over 1, or just square root of 3. Now, what did I forget? The negatives, because I'm a dork. All right, so negative square root of 3. All right. Thoughts on those? Oh, I don't know why it's not writing. Okay. Okay, last thing, best thing. This is just conversation about coordinates of that point. How do we get the coordinates of the point? Right? Well, the good news is, right? The good news is this is an X and this is a Y. Okay? It's an X and a Y. So we just want to frame it in a different way. We want to label it in a different way. On our unit circle, or on our circle earlier, we said cosine at theta was x over r, and that sine at theta was y over our radius for any circle, okay? So basically what I want to do is just solve for x, all right? If I solve for x in that first relationship, what would I get? What would x equal? How would I get x by itself? Multiply by r, so r cosine of theta. And what would y be? r sine theta. Okay, so if I have a radius, all right, other than 1, my x coordinate, so another way to write that ordered pair is r cosine theta, comma, r sine theta. Okay, so it's just another way to write an ordered pair. All right, and it just comes from those trig relationships we had earlier, okay, where we married the two together. Cosine is x over r, sine is y over r, so x is r cosine, y is r sine. Okay. So let's put these two to practice. All right. It says the figure above shows the circle, it's actually beside it, with radius 4 along the equilateral triangle PQO. Which of the following gives the coordinates of point Q? So we want to eventually get the points over here. Okay. Right, heifer. Okay. All right. So how would we approach that? Well, just looking at that and thinking unit circle, which family is closer up there to the y-axis? Pi over 3. That's exactly what I think it is. Okay. So if it's pi over 3 in the first quadrant, what's it going to be in the second quadrant? 2 pi over 3. Okay, so we're just naming the arc length. All right, we're naming the arc length. We also know that the radius is equal to 4. Okay, because they told me the radius is equal to 4. All right. So if we're going to list the ordered pair right here at Q, right, I want the x and the y coordinates. I'm no longer interested in the 1/2 square root of 3 over 2 mess. All right, I just want to write it as an expression. And so x is going to be r times the cosine of theta, y is going to be r times the sine. And I just need to know that theta at that point where we're talking about. So for cosine, we know the theta is 2 pi over 3. For sine, 2 pi over 3, which would be C. All right, that's all we're doing is just renaming that ordered pair at that arc length. All right, let's do one more. This one's a little bit different, okay? It's asking me some different things, okay? It says the figure shows the circle of radius r along with the line y equals negative x. It intersects, the circle and the line intersect at the points R, O, and P. If the coordinates of P are 6 square root, helps if you write that right, 6 square root of 2, negative 6 square root of 2. What's the value of r? Okay, so it's asking me to find something totally different this time. Okay, totally different this time. So if I know point P, does the radius change depending on what quadrant I'm in? No, the radius is constant. Okay. So if we thought about the right triangle that got me to that point, all right, x was 6 square root of 2, y was negative 6 square root of 2, could I find r? Yeah, okay. Use Pythagorean theorem, x squared plus y squared equals r squared, all right? This is simply a Pythagorean theorem problem, all right? So if I plug those values in, 6 square root of 2 squared plus negative 6 square root of 2 squared is going to equal my r squared. All right? Now be careful right here. All right? If I take 6 and square it, I get 36. If I take square root of 2 and square it, what do I get? 2. Okay? So you're going to have to remember that you got to square both of those things. All right? Plus negative 6 and square it, I get 36. Square root of 2 squared, I get 2. All right? So I'm getting 72 plus 72 is r squared. 144 is r squared. So what's my radius? It's 12. Okay, so just use the Pythagorean theorem on that one. All right, x squared plus y squared equals our r squared. All right, questions about today? A lot more straightforward than the application stuff. All right, so 3 worksheets. We're going to do a little bit of stuff on all of them. Okay, they have a ton of problems on them, but we're just doing a few. All right, on worksheet A for 3.2, 1, 2, 4, 8, 12, 13, 14, and 15. Just tried to give you a good variety of all the things. Okay. On worksheet B for 3.2, we're going to do 5, 6, 11, 16, 19, and 20. And then on the last one, worksheet A for 3.3, 1, 2, 3, and 4. Okay. You do have a wrap-up today on Google Classroom, so let's get that done. You got time to practice.